So in this example problem, we're going to use the principles of stoichiometry, of mass balance, to figure out the amount of product that we make in solution when our two reactants start out in solution as well. The question is, what concentration of barium nitrate is produced by the reaction of 125 milliliters of 0.6 molar nitric acid with 175 milliliters of 1.3 molar barium hydroxide? Our first step in solving any stoichiometry problem where we're trying to find the amounts of reactants or products is to always write the balanced chemical equation. So step one is write the balanced chemical equation. And to start with, we want to make sure that we can write the equation unbalanced. So let's see what we have here. We've got barium, hydroxide, and nitric acid as our reactants. So nitric acid is HNO3, and that's in solution, so aqueous, plus barium hydroxide, BaOH2, aqueous. And I have to have two hydroxides in there for every one barium, because we know from the periodic table that barium has a 2+ charge, and we know from our knowledge of polyatomic ions that the hydroxide has to have a 1- charge. So you have to have two hydroxides to balance out every one barium. And what are we going to get from this? We're going to make barium nitrate, so BaNO3. Remembering again that NO3 has a 1- charge, so we need two of them to balance out the bariums. The problem is asking concentrations. We might assume that barium nitrate is soluble, but we would probably want to look at the solubility rules to figure out that all nitrate compounds are soluble in water. And so, yeah, barium nitrate, we're going to put an aqueous symbol here to say that it does dissolve in water. And then our other product always, when we're having a strong acid reacting with a strong base, is going to be water, so H2O. And we'll put that as a liquid. Okay, so now I need to balance this chemical equation. And I think I'm going to start with the nitrate ions here, because that's going to be sort of the most complicated piece of this, it looks like, is balancing out the nitrogens and the oxygens. So if I've got two NO3s on the right-hand side, then I know I've got to have at least two on the left. So you need two HNO3. If I add up what I've got on the left and the right now, I need to make sure that my H's are balanced, my N's, my O's, and my bariums. I ran out of space here. So let me just scoot that up a little bit. So HNO and barium. HNO and barium. So now I've got two hydrogens here and two over there, so I've got a total of 4 on the left, and I've only got 2 over here on the right, so I'm going to need to put a 2 in front of the H2O. So now I've got 4 hydrogens on the right. Look at my nitrogens. I've got 2 on the left from over here, and I've got 2 on the right from right here. So 2 on the left, 2 on the right. That works out. And then I want to look at my oxygen. So I've got 6 oxygens on this compound, and I've got 2 over here. I've got 6 here, and I've got 2 here. So I've got a total of 8 on the left and a total of 8 on the right. And then I've got 1 barium on each side. So I have everything balanced in terms of conservation of mass. So now I can use those ratios in my chemical equation to figure out the amounts of product that I'm going to get out of this reaction. So now I have my balanced chemical equation. My next step in figuring out the amounts of things I'm going to make is to find the number of moles that I actually have. So step 2 is to find the number of moles. So in this case, we're given the volume and concentration of these things. These are our two reactants. So we're going to be finding the numbers of moles of reactants here to start with. And then we can use that to find the numbers of moles of products from our balanced chemical equation. So to find the number of moles of nitric acid, so HNO3, I am going to take the volume, but I'm going to have to convert the volume to liters, so 0.125 liters of HNO3 times 0.600 moles per liter. So that's going to give me 0.075 moles of HNO3 to work with. And then I want to find the number of moles of my other reactant. So I've got 175 milliliters, so 0.175 liters of barium hydroxide, and it's 1.30 moles per liter. So that is going to give me 0.2275 moles of barium hydroxide. So step 4 is to take the amount of reactants we have and convert this to amount of product in this problem. But we need to know in this case which of these two reactants is what we call our limiting reactant. There's a variety of ways to figure this out. I think one of the easiest ways is to just see which of these amounts of moles, the 0.075 moles of nitric acid or the 0.2275 moles of barium hydroxide, gives the smallest amount of barium nitrate, because we can't make any more after we've used up one of our reactants. So whichever one leads to the smaller amount, that's the limiting one. That's the one that limits how much we can make. So let's look at the mole ratio. So we get 1 barium nitrate for every 2 HNO3s, and we know that we have 0.075 moles of HNO3. So that means using up all of that HNO3 would give us 0.0375 moles of barium nitrate. Oops. So if we could make more than that from our barium hydroxide, we would know that the nitric acid is the one that's going to limit us. Okay, so again, I can cancel those out, so I get moles of barium nitrate. So let's see how much we would make if we used up all the barium hydroxide instead. And this one's fairly obvious because we get 1 barium nitrate for every 1 barium hydroxide that we have. And so when I multiply that by the number of moles of barium hydroxide, I can make just as much barium nitrate as I have barium hydroxide. So 0.2275 moles of barium nitrate in that case. And so clearly we can make way more if we were to use up this stuff, but this nitric acid is going to get used up far before we use up all that barium hydroxide. So that means that we're going to get, out of this reaction, 0.0375 moles of barium nitrate. But now the question is asking us, what is the concentration of barium nitrate? So all we need to do to get to the concentration of barium nitrate is divide that number of moles, so 0.0375 moles, by the total volume, which we've got 125 milliliters plus 175 milliliters. And we want to get this into liters because we want concentration in molarity usually. So 125 plus 175 milliliters equals 300 milliliters, or 0.300 liters, which gives us a final concentration of 0.125 molar barium nitrate.